Alright, we're talking about surface area of pyramids and cones. Objective, I've learned to apply the formula for surface area on a pyramid and a cone. Real quickly, let's define some things. Vertex, remember that that's the point opposite the base of the pyramid. And a regular pyramid means that your base is a regular polygon. The lateral faces are congruent isosceles triangles. That's going to be important. And then the slant height, you got to be able to recognize what that is. That's the height of the face, one of the faces, one of the lateral faces. The other thing is the altitude of a pyramid is the perpendicular segment from the vertex to the plane of the base. So that would come, if it's a regular pyramid, that's going to come straight down the inside of a pyramid down at a 90-degree angle. If it's a non-regular pyramid, then it's going to come out somewhere not on the center. So it might come down kind of something like this, where the height would be out somewhere from the center of the base. Kind of real quick to show you where this comes from, the formula comes from. The lateral faces of a regular pyramid can be arranged to cover half of a rectangle with a height equal to the slant height of the pyramid. So basically they took out all of these sides right here and kind of faced or laid them out side by side, and it creates this, what ends up being half of a rectangle. Okay, and the perimeter would be that 4S. So let's get to the formula real quick. The lateral area of a regular pyramid then is going to become 1/2 the perimeter of the base times the slant height. The total surface area is going to be 1/2 PL plus B, where B is the area of the base. Alright, so let's kind of split this up. We need to find the lateral area first of a square pyramid. So my lateral is equal to 1/2 P times L. So again, good habit to get into. Go ahead and find the P and the L so that all you have to do is substitute. It says it's a square pyramid with a base edge length of 14 centimeters. So because it's a square, then it's going to be 14 times 4 for my perimeter, which ends up being 56. And then the slant height is 25. So they gave me that one. Round to the nearest tenth. So we got 1/2 of 56 times 25. Which I get 700 centimeters squared. Right. And then we need to find the total surface area, which is 1/2 PL plus B. Again, notice right here, this 1/2 PL is the lateral surface area. Since we already found that, all you have to do is substitute that in. But we do need to find the B. So B is area of the base. The base is a square, so I know that that is going to be 14 times 14, or 14 squared, which ends up being 196. So I got 700 plus 196, which ends up being 896 centimeters squared. So that is my lateral surface area and my total surface area of a regular square pyramid. Alright, on this next example we have a regular pyramid, and it looks like this base down here is a hexagon. So we're going to have to do some things, some work on this one. 1/2 PL. For this first part, they gave us a hexagon, and it's a regular hexagon. So then I know my P is going to be equal to 10 times 6, which is 60. And I know my slant height is 16. So my formula is going to be 1/2, or my equation is going to be 1/2 of 60 times 16, which ends up being 480 inches squared. Now I'm going to need to find my total surface area. It's 1/2 PL plus B. Again, we know that 1/2 PL because we just did that. 480 plus my B now. So we got to do the area of the base. Here's where you have to remember how to find the area of a regular polygon. Remember that the area of a regular polygon is 1/2 the apothem times the area of the times the perimeter of the base. So we know the perimeter of the base. We have to find the apothem. So I'm going to kind of draw a hexagon right here. I know that the base is 10. Remember that the apothem goes from the center of the base perpendicular to the side. So here's my A, and I need to find my radius, or my apothem. I know my radius is 10. This piece right here cuts it in half. So I would have A squared plus 5 squared equals 10 squared, if you want to use Pythagorean theorem. If you remember how to do your 30, 60, 90 triangles, then I know very easily that my A comes out to be, my apothem comes out to be 5 square roots of 3. Alright, so for the area of this, I get 1/2 5 square roots of 3, and then my perimeter is 60. So then I get an area of 150 square root of 3. Alright, that's actually ends up being my B, so I guess we should make that a B for all of these. So my area of the base is 150 square roots of 3. Alright, so then I would put that, substitute that into the B, 150 square roots of 3. Now if I actually ask you, or if I don't tell you to round it, this is the answer I'm looking for. I can't combine these because this does not have a square root of 3 attached to it. However, if I do ask you to round, then you can go ahead and put that in the calculator. So let's go ahead and do that. You've got to be able to do both. So if I round this out to the nearest tenth, that's going to give me 739.8 inches squared. Alright, this next example 3, I'm going to leave that one for you to try, so you can check that with me. Now we're going to move on to the cone. And it's similar. The vertex of the cone is opposite the base. The axis of a cone is a segment with the endpoints at the vertex and the center of the base. So this would be my axis, or my axis of the cone. The axis of a right cone is perpendicular to the base. The axis of an oblique cone is not perpendicular to the base. So that's why you see this 90-degree angle here, but you don't see anything on this drawing over here. Alright, and then let's go look at the formula. Much like the pyramid, you do have a slant height. So let's look at this formula. The lateral surface area is equal to pi times radius times the slant height. The total surface area is pi RL plus pi r squared. Notice that on this one, the reason if you're looking at this particular one, there's only one base, so that's why it's just pi r squared. Unlike the cylinder that has 2 bases, this one only has 1. Alright, let's go ahead and do this example. Find the lateral area and surface area of a right cone with a radius 9 and a slant height of 5 centimeters. For this, sometimes it's good to draw a picture. Sometimes it helps, or sometimes you need a picture. It says that my radius is 9, and my slant height, that's going to be this part right here, that's going to be 5 centimeters. Okay, so my lateral surface area is pi times radius times my slant height. I know my radius is 9, my slant height is 5, so I just have to substitute here. Pi times 9 times 5. Remember that I can move this pi symbol just to the end, and so I have 9 times 5 pi, which ends up being 45 pi centimeters squared. That's my lateral surface area. Now I need to look at my total surface area, which is pi RL plus pi r squared. Pi RL we've already done, so we know that that comes out to be 45 pi plus my radius squared, that's going to be pi times 9 squared, which is 81. So I have 45 pi plus 81 pi. I can combine those, and I get 126 pi centimeters squared. Alrighty then, here's another one, or here's one for you to try. I will get you started. Notice that they gave you the height, or the altitude. They gave you the radius. You're going to have to find the slant height. So a little clue for somebody that might need it: a squared plus b squared equals c squared. Good old Pythagorean theorem. That's going to help you solve this example. Alright then, on this one we want the surface area of the composite figure. Notice that we have a cube, and then we have this pyramid that's kind of inverted, sitting inside the cube. Alright, so I'm going to kind of go ahead and start by finding this total surface area of the cube. Alright, and then if you may or may not recall, but from the previous lesson, that was equal to 6 times the side squared. And my sides are 2, so that's going to equal to 6 times 2 squared, which comes out to be 24 yards squared. But this base up here is not included. There's a hole in there, so I have to take out one of my squares. So the area of one face is going to be equal to 2 times 2, which is 4. So I need to take that out of my square, my surface area of the square. So that's going to be 24 minus 4, which is 20 yards squared. Right, so that gives me all of these 5 sides. The one on the left, this front one, the right one, the one right here in the back, and then this bottom base right here. Now we got to focus on this upside down pyramid. Right. And since I don't want this right here, what I end up needing is I need the lateral area of the square pyramid, which is going to be 1/2 perimeter times my slant height. Alright, so the perimeter of this base right here is going to be 2 times 4 because there's 4 sides. So P is equal to 2 times 4, which is 8. Now for my lateral surface area, I'm going to have to do a little calculation. And if I were to take this pyramid right here and kind of sit it to where I'm looking at it like so, and I'm looking at it straight on where I don't see this hole up here, I know that this total distance here is 2. So when I draw my height right here, I'm going to cut this in half, so that's going to be 1. And because it's a cube, I know that this height right here is 2. So I can use this to find my slant height. I'm going to use Pythagorean theorem. I'm going to have 1 squared plus 2 squared is equal to my slant height squared. So it's 1 plus 4, and that's 5. So my slant height is equal to the square root of 5. Okay. So now we can substitute for this 1/2 8 times the square root of 5, which ends up being 4 square roots of 5. Alright, so I want the total surface area, that's yards squared. So then that means I need to put this together, I need to add it to this right here. So my answer is going to be 20 plus 4 square roots of 5 yards squared. Okay, because I would need to add all the faces of the square minus this top base, and then the lateral surface area of this square pyramid. So that's what I get for my answer.